CERN's collider data shows particles behaving wrong, in ways nobody predicted. Not measurement error or calibration issues affecting the detector systems. The kind of wrong that breaks physics at its most fundamental level. And nobody outside the physics community is talking about it yet. For 50 years, the Standard Model has been physics' undefeated champion theory. It predicted the Higgs boson decades before we built machines to find it. Scientists mapped every fundamental particle that exists in nature we know about. Every force carrier that mediates interactions between matter throughout the universe. The entire quantum recipe that makes reality work the way it does. Physicists tested it 17,000 different ways, over 5 decades of experiments. It passed every single challenge they threw at it with perfect accuracy. Perfect mathematics, everywhere you looked, throughout nature, at every scale tested. When you learned chemistry in school, those electron shells around atoms existed. That's Standard Model physics, predicting how electrons arrange themselves in orbitals. The GPS satellite constellation navigating your phone through city streets uses calculations. Standard Model mathematics running in the background, correcting for relativistic effects constantly. Nuclear reactions powering the sun for 4 billion years without stopping once. Standard Model physics predicting every step of the fusion process perfectly, accurately. This isn't some abstract theory professors argue about in ivory tower universities. It's the confirmed, tested, verified foundation of how matter works fundamentally. The bedrock of modern technology and our understanding of reality itself. Until 3 months ago, when something impossible appeared in the data. CERN's Large Hadron Collider detected something that shouldn't exist under known rules. The most precise scientific instrument humanity has ever built in history. 27 kilometers of tunnel, buried deep under the French-Swiss border. Superconducting magnets cooled to temperatures near absolute zero to function properly. Protons accelerated to 99.9999% light speed. Collision energies recreating conditions from microseconds after the Big Bang occurred, all to test whether our equations actually match reality at fundamental scales. And they found a pattern appearing in particle decay rates consistently, one that shouldn't exist under any known rules of physics we have. Not occasionally as some random fluke you'd expect from quantum uncertainty effects. Appearing consistently across millions of collisions recorded every single day for months. The kind of consistency that means something genuinely real is happening here. Here's what makes it genuinely alarming to physicists watching this unfold right now. The crack isn't appearing in just one experiment at one facility somewhere. It's showing up everywhere scientists look closely enough at the data carefully. Different detectors built by different teams using different technologies and methods. Different particles being studied under different conditions at different energy levels. Different research groups on different continents analyzing data independently from each other, all finding the same impossible pattern, staring back at them from results. This is the thesis you need to understand right now about what's happening. We're not discovering new particles anymore like we did with Higgs boson. We're watching the fundamental rules themselves fail in real time, under scrutiny. The equations that predicted everything for 50 years are breaking down now. And the implications are bigger than most people outside physics realize yet. Start with beauty quarks decaying inside the LHCb detector at CERN facility. Beauty quarks are heavy versions of the down quark, found inside protons. They only exist for tiny fractions of a second before decaying away. When they decay, they can turn into either electrons or muons equally. Here's what the Standard Model says about electrons and muons very specifically. They're identical particles, except for mass, with no other differences at all. Muons are just heavier versions of electrons, weighing 200 times more. Different generations of the exact same type of fundamental particle in nature. They should behave exactly the same way in every quantum interaction possible. Think of them like identical twins who happen to weigh different amounts. Everything else about their behavior should match perfectly under all conditions tested. But beauty quarks are choosing electrons over muons by 3% consistently, appearing in every single dataset collected over months of continuous operation. Every time scientists run the experiment with fresh data samples independently. 3% sounds small until you understand particle physics precision standards operate. These predictions work accurately to 12 decimal places for most measurements taken. Getting the percentage wrong by 3 whole percent is catastrophic at this scale. It's like GPS thinking you're in a completely different country altogether. The error is absurd. At the scale these calculations normally operate perfectly. They ran the experiment again with completely fresh calibrations, from scratch. Same result, showing the 3% preference for electrons over muons. Clearly. Different detector on the opposite side of the collision point entirely? Same violation staring back at them from independent measurements using different equipment. Switch to different particle beam energies to test energy dependence thoroughly. The pattern still persisted across all energy ranges they could test. The anomaly refused to disappear, no matter what they tried changing. That was crack number 1, appearing in the foundation of physics. Then the muon measurements started coming in from Fermilab and CERN independently. The muon's magnetic moment measures how strongly it responds to magnetic fields. Quantum field theory predicts this number to 12 decimal places accurately, always. For electrons, the prediction matches measurements perfectly to 11 decimal places. For tau leptons, the match is perfect, again, to the limits of measurement. But the muon measures too high compared to standard model predictions consistently, off by parts per million at the 9th decimal place, every time. Quantum field theory calculates these values from fundamental symmetries of nature itself. Getting 12 decimals correct isn't luck or approximation in these calculations. It's the theory accurately describing reality at quantum scales with precision. Getting the 9th decimal wrong is like your bank account being off significantly. You notice immediately because everything else works perfectly, to the penny, always. One anomaly in particle physics is interesting enough for a published paper. 2 anomalies in related particles starts looking like a real pattern emerging. That was crack number 2 opening wider in the foundation structure. Then, Atlas detector measured the W boson mass in 2022. W bosons carry the weak nuclear force through all matter, everywhere, consistently. They're fundamental to how atomic nuclei decay across the universe, naturally. The standard model calculates their mass with extreme precision from first principles. CERN measured it 7 sigma heavier than the prediction from theory. 7 sigma means the odds of this being random chance are infinitesimal. Specifically, 1 in a trillion chance this is just statistical noise alone. This isn't statistical noise or a measurement fluke from detector errors. This is reality screaming that something's fundamentally wrong with our equations. The W boson isn't some exotic particle appearing under rare conditions only. It mediates radioactive decay in rocks beneath your feet right now, continuously. Solar fusion reactions in stars throughout every galaxy in the universe. Supernova explosions, creating heavy elements across cosmic history over billions of years. Every beta decay event that's ever happened anywhere throughout cosmic history. If its mass is wrong in our equations by 7 sigma, significantly, every calculation built on that number becomes immediately suspect and questionable. Models predicting how stars live and die over billions of years. Calculations of nuclear reaction rates happening in fusion processes throughout nature. Predictions of supernova energy output we've been making for decades confidently. Everything downstream that depends on W boson mass being correct fundamentally. Yet the sun still burns steadily on schedule for billions of years. Supernovae still explode with predicted energy releases matching observations from telescopes. The structure holds perfectly, but the materials are provably wrong, somehow mysteriously. Like discovering your house foundation is actually foam, but it stands anyway. That was crack number 3, splitting the foundation wide open completely. Here's what makes this terrifying and wildly exciting simultaneously for physicists. These aren't edge cases happening at the absolute limits of measurement capabilities. These aren't exotic conditions we only create in laboratory experiments artificially. These are common particles doing everyday quantum business throughout the entire universe. The foundation stones of matter itself behaving incorrectly under close scientific scrutiny. And every possible explanation scientists have proposed creates more problems elsewhere. Start with supersymmetry, which has been the leading candidate for decades. Every standard model particle might have a heavier partner we haven't detected. Photons would have photinos as their supersymmetric partner particles in theory. Quarks would have squarks as their corresponding supersymmetric partner particles too. The electron would have a selectron as its supersymmetric partner particle. These superpartners could elegantly explain dark matter's existence throughout galaxies everywhere. Could unify all forces into one framework at high energies beautifully. Could fix the Higgs mass problem that's bothered theorists for years. But CERN's collider has been hunting superpartners relentlessly for 15 years straight. Absolutely nothing has appeared in any dataset collected over those years. Not even faint hints in the data suggesting they exist anywhere. No excess collision events showing up where theory predicts they should appear. No unusual signatures appearing in any decay channels examined systematically. Complete silence where theory predicted we'd find something clearly by now. The cracks in our data suggest something's definitely hiding there somewhere. But it's concealing itself far better than supersymmetry predicts is possible. Maybe the superpartners are heavier than our collider can reach currently. Maybe they simply don't exist in nature at all, anywhere, ever. Try another explanation, involving new force carriers we haven't discovered yet. A Z-prime boson, significantly heavier than known force carriers already discovered. It could couple differently to electrons versus muons by fundamental design intentionally. That would explain the beauty quark preference we're seeing perfectly in data. The asymmetry would be real physics, not a violation of anything fundamental, but Z-prime particles should show distinctive signatures in other places too. Dedicated searches at multiple facilities, looking specifically for them, have run. Results come back empty, consistently showing nothing where something should be. Every energy range examined carefully has shown no evidence whatsoever. Every decay channel investigated systematically shows nothing unusual at all. Nothing appears where theory says we should definitely see something clear. The data says something new must exist to explain the anomalies appearing. Other data says nothing new exists anywhere we've looked carefully so far. Both statements cannot be simultaneously correct under normal logic we understand. A third candidate worth considering seriously are particles called leptoquarks in theory. Hypothetical particles that transform quarks into leptons and back again continuously. They'd naturally create the electron-muon asymmetry appearing in our data clearly. They fit the beauty quark measurements beautifully, in theoretical models perfectly. But leptoquarks also predict other effects we're definitely not observing anywhere. They should noticeably change proton decay rates across the board significantly. Protons should decay faster than the standard model predicts they should naturally. Experiments have been watching protons for decades, looking for any decay signs. Super Kamiokande in Japan uses 50,000 tons of pure water continuously, watching for even a single proton decay event per year to appear. Protons appear perfectly stable under every test we can devise to check. No excess decay events anywhere matching leptoquark predictions from theory clearly. No signature screaming in the places theory says it should appear obviously. Do you see the pattern emerging here? Across all these explanations? Every explanation fixes one crack beautifully, while opening another crack somewhere else. The puzzle refuses to resolve into clean, coherent answers that work everywhere. Each solution creates new contradictions with other established observations we've made. Some physicists are starting to wonder, something more radical now than before. What if quantum field theory itself has fundamental flaws we never noticed? The entire mathematical framework everything's been built on for 80 years straight. QFT assumes particles are point-like excitations, vibrating in underlying quantum fields. What if they're not actually point, like at all, fundamentally speaking. What if scale matters more fundamentally than current theory allows or predicts? At sufficiently high energies, particles might behave completely differently than expected. Not new particles requiring discovery through experiments at high energies. New rules entirely, requiring completely different mathematics to describe reality properly. This would require rewriting quantum mechanics from scratch, immediately and completely. 8 decades of established theory thrown out the window overnight, suddenly. Physics textbooks burned and completely rewritten from first principles again. University curricula redesigned entirely to teach new frameworks to students. Everything learned and taught confidently would need complete revision from scratch. Nobody wants that level of upheaval, obviously, in the physics community. It would be chaos for the entire field for years or decades. But nature doesn't care what we want or find convenient for us. Nature does what it does, regardless of our preferences or comfort. The most likely scenario physicists won't say out loud publicly yet? All 3 anomalies share one single underlying cause, connecting them all together. One new particle or one new force explaining everything simultaneously and elegantly. The W boson measuring 2 heavy by 7 sigma from predictions. The muon magnetic moment measuring 2 strong by parts per million consistently. Beauty quark asymmetry in decay paths, choosing electrons over muons preferentially. All connected through one elegant explanation we haven't conceived yet, somehow. But we haven't found it because it's hiding somewhere completely unexpected. Current theory says certain regions of possibility must be empty, by definition. The mathematics declares these spaces physically impossible to contain anything at all. We drew boundaries confidently based on our equations working perfectly elsewhere. The cracks suggest we drew those boundaries too hastily, without proper justification. Reality exists in places our theory declared should be completely vacant forever. Here's the historical parallel keeping physicists awake at night right now. Early 1900s looked almost exactly like this current moment in history. Physics seemed basically solved with just a few loose ends remaining unresolved. A couple small problems to clean up before declaring victory completely. Then, blackbody radiation wouldn't cooperate with any predictions from classical theory. Photoelectric effect made absolutely no sense under existing theory at all. Atoms somehow didn't collapse inward like equations said they absolutely must. Mercury's orbit around the Sun deviated slightly from Newton's predictions, consistently. These seemed like minor technical problems at first, to most physicists. Small discrepancies that better measurements would surely resolve quickly and easily. Just a matter of time before everything aligned properly again, perfectly. Within 30 years, everything fundamental had been completely rewritten from scratch. Quantum mechanics emerged from trying to solve the photoelectric effect problem. Relativity emerged from trying to make electromagnetism work correctly with motion. The loose ends were actually foundation cracks all along, hiding deeper. Everything physicists thought they understood had to be rebuilt completely anew. We're standing at that exact same pivotal moment in history right now. 3 independent anomalies appearing in 3 different experiments on different continents. That's not coincidence or random chance or measurement error appearing randomly. That's a recognizable pattern physicists have learned to identify through history. Patterns in physics always mean something real is happening in nature. CERN is upgrading the Large Hadron Collider to higher luminosity very soon. 10 times more collisions per second than current operations allow right now. Exponentially more data to search for clearer patterns in the noise. They're building entirely new detectors, specifically targeting these anomalies head-on. Instruments designed entirely around finding what causes the cracks to appear. The Atlas detector is getting precision tracking upgrades for better measurements. CMS is installing new timing detectors to catch particles we're missing currently. LHCb, where the beauty quark anomaly appeared, gets completely rebuilt components. But CERN isn't the only facility hunting these cracks aggressively worldwide. Bell 2 in Japan targets beauty quarks specifically, with dedicated, upgraded equipment. They're running the same experiments from a completely different angle, independently. Independent confirmation from different continents, using different detector technology and methods. That's how science proves something is real versus systematic error in measurements. Fermilab's Muon G-2 experiment refines magnetic moment measurements continuously, looking for identical patterns from different angles with different experimental methods. Their results match CERN's Muon measurements almost perfectly now, from independent work. Two facilities on two continents seeing the same impossible deviation in data. That's not coincidence anymore, appearing randomly in separate experiments independently. That's confirmation something genuinely wrong is happening with muons in nature. China is building a circular collider, twice CERN size, for the 2030s, scheduled to begin operations in the next decade with higher energies, designed to smash through current energy limits we can't reach yet today. Higher collision energies might reveal particles hiding just beyond current reach, or might show the cracks get worse at higher energies tested. The global physics community is intensely focused right now, simultaneously worldwide, coordinated across continents and time zones, sharing data in real time. This is collaborative science, operating at unprecedented scale in human history. 10,000 physicists working together on the same fundamental problem, collaboratively. If the cracks are real, multiple independent confirmations will arrive from facilities. Science demands reproducibility before accepting any revolutionary claims about nature, definitively. One experiment finding something weird is interesting, but not conclusive proof alone. 3 experiments finding the same thing is a pattern worth investigating seriously. 5 experiments across 3 continents finding identical patterns is reality showing itself. The next major run starts in 2025 with upgraded equipment. If the discrepancies grow stronger with 10 times more data collected carefully, confirmation arrives that something genuinely new exists beyond standard model physics. New particles we haven't imagined yet existing in nature, waiting for discovery. New forces we haven't detected yet, mediating interactions we don't understand. New rules we haven't written down yet, governing reality at fundamental scales. If they fade into statistical noise instead, with better measurements and calibrations, we've got systematic errors to identify and fix in our instruments carefully. Calibration issues hiding in complex detector responses we didn't account for properly. Background noise we didn't account for correctly in our data analysis procedures. Still fascinating, but not revolutionary physics changing our understanding of nature fundamentally. Both outcomes would reshape the field of physics completely going forward. Permanently. Discovery means new particles or forces, requiring new theoretical frameworks from scratch. Textbooks rewritten from scratch for the next generation of physics students worldwide. No discovery means our most precise instruments have subtle flaws we missed. Also requires textbooks rewritten, explaining how we missed this systematically somehow. Either way, nothing stays the same after 2025 results come in. But here's what matters for everyone watching this, not just physicists professionally. Why should you care about particles behaving strangely in underground tunnels far away? All modern electronics rely on quantum mechanics working exactly as predicted, always. Transistors powering your phone depend on electron behavior being perfectly understood, completely. The entire field assumes we understand electron behavior at quantum scales perfectly. If the standard model is wrong about leptons, quantum error correction fails. The qubits we're engineering right now might have fundamental instability issues lurking. Fusion reactors depend on precise nuclear reaction rate calculations being correct perfectly. We're building ITER in France right now for $50 billion total cost. It's designed using standard model predictions for how nuclei fuse together exactly. If W boson mass is wrong, every reaction rate calculation becomes suspect immediately. The reactor might not achieve the energy output we've promised governments funding it. Plasma confinement depends on understanding exactly how particles interact at high temperatures. Get the physics even slightly wrong, and fusion doesn't happen efficiently enough. Particle beam cancer therapy targets tumors with proton beams, precisely calculated for depth. Doctors calculate exactly how deep the beam penetrates before stopping completely inside tissue. Too shallow, and you miss the tumor entirely, wasting treatment time for patient. Too deep, and you damage healthy tissue beyond the target area, harming patient. Those depth calculations assume our particle interaction physics is perfectly correct. Always. If proton behavior deviates from predictions, patients receive wrong dose placement dangerously. Room temperature superconductors are the holy grail of material science currently, worldwide. We're searching for them using quantum mechanics predictions about electron pairing mechanisms. If our understanding of electron behavior has cracks, we're searching wrong completely. We might be looking in entirely wrong materials, or wrong conditions altogether. The next revolutionary material might require physics beyond the standard model entirely. Advanced materials, designed at the atomic level for specific desired properties needed. Graphene transistors being developed for next-generation electronics applications coming soon. Carbon nanotube composites for aerospace applications, requiring extreme strength-to-weight ratios. Metamaterials with impossible optical properties, engineered atom by atom for specific functions. Every design assumes the standard model describes atomic bonds correctly and precisely. One small deviation in electron behavior breaks the entire design process completely. We'd be building revolutionary technology on foundations we now know contain faults. Like constructing skyscrapers when you know the concrete formula is wrong somehow. The blueprints would need serious revision, mid-construction, everywhere, simultaneously, worldwide. Engineers would need to account for effects the standard model doesn't predict. Effects we don't understand yet, because we haven't found their cause precisely. This has happened before in history, with remarkable regularity actually, throughout time. The transistor emerged from quantum mechanics research in the 1920s, initially. Pure theoretical work, with no immediate practical applications in sight whatsoever then. 60 years later, personal computers emerged for everyday consumers to buy. Everywhere. Now there are billions of transistors in the device you're watching this on. GPS satellites use relativity corrections in their positioning calculations constantly, every second. Without accounting for time dilation, they drift kilometers off daily, making them useless. General relativity was pure abstract theory for 50 years before any practical use. Then suddenly, it became essential infrastructure for global navigation systems used worldwide. Whatever we discover about these cracks won't immediately change daily life tomorrow. The revolution happens slowly in physics, then all at once in technology. But in 2080, this discovery might power absolutely everything around us. The LED lights illuminating your room exist because someone studied quantum wells. Nobody cared about quantum wells initially when they were just theory nobody understood. Now they're in every screen and light fixture manufactured globally by billions. We're funding today's abstract particle physics research, happening at CERN right now. Future generations will reap enormous practical benefits we can't predict yet clearly. We're literally doing it right now, with technology from 1920s quantum discoveries. The same pattern repeats throughout scientific history, without exception, every single time. The standard model served humanity incredibly well for 50 years of progress. It's not wrong so much as incomplete in ways we're discovering right now. Newton's laws weren't wrong when Einstein came along with relativity either, actually. They still work perfectly for everyday scales and normal speeds we experience, just not at relativistic velocities approaching light speed in extreme conditions, not at quantum scales smaller than atoms, where different rules apply. The standard model will remain useful for most practical applications forever, probably, but edge cases will require entirely new mathematics to handle correctly going forward. Technologies operating at extreme scales beyond what we've built so far. Energies we can barely reach in our most powerful accelerators currently available. We're mapping the boundary carefully between where old physics works perfectly fine and where it breaks down, requiring something new to take over completely. Finding where the map says, "Here be dragons," and discovering dragons actually exist. 3 anomalies in the foundation of reality itself, appearing in data consistently. 3 different experiments on different continents, finding the same impossible patterns independently. 3 cracks that refuse to be explained by current theory we have. 3 pieces of evidence pointing towards something genuinely new hiding in nature. The standard model predicted everything for 50 years, with perfect accuracy, always. Every particle discovered, right on schedule, exactly where equations said it should be. Every force carrier behaving exactly as mathematics demanded it absolutely must behave. Perfect predictions everywhere physicists looked throughout nature, at every scale tested. The most successful scientific theory in human history, by any measure you choose. Then, 3 months ago, particles started choosing paths equations call impossible, consistently. Not occasionally as random quantum flukes you'd expect sometimes from uncertainty alone. Appearing consistently in data collected day after day after day, reliably. The pattern is undeniable now, appearing in millions of collisions recorded worldwide. This isn't about finding new particles to add to the list anymore. It's about watching the fundamental rules themselves break in real time, visibly. The equations we trusted completely are failing under close examination and scrutiny. The foundation we built everything on contains cracks showing up everywhere now. The cracks aren't destroying physics as a field at all, fortunately for us. They're revealing where we drew the map too confidently, too soon, historically. Where our certainty about reality was premature and unjustified by evidence fully. Where we declared problems solved that were merely hidden temporarily from view. Nature is showing us the boundaries of our current understanding right now. Every major theory in history fell exactly this way historically, without exception. Small anomalies that seemed unimportant initially to most people studying them, gradually widening into full revolutions that changed everything completely and permanently. Mercury's orbit deviating slightly from Newton's predictions started relativity revolution eventually. Blackbody radiation not matching classical predictions started quantum mechanics revolution entirely. Photoelectric effect making no sense led to photon concept changing everything. This is that pattern repeating itself again right before our eyes currently. We're watching it happen in real time at CERN, right now, today. The data flows in daily from detectors running continuously around the clock. The anomalies persist despite every attempt to explain them away as errors. The foundation continues cracking wider under increasingly precise scrutiny from scientists worldwide. More data arrives every day, making the pattern clearer and more undeniable. 2025 brings upgraded detectors with 10 times the sensitivity currently. We'll know more definitively within 2 years whether this is real or not. Either confirmation of new physics beyond the standard model existing in nature, or discovery of subtle systematic errors hiding in our instruments we missed. Either outcome changes physics completely going forward for decades to come, inevitably. And when the answers finally come, they will rewrite everything we know. Everything we thought we knew about matter at its most fundamental level. Everything we thought we knew about forces mediating interactions throughout the universe. Everything we thought we knew about how reality works, fundamentally, at deepest scales. The cracks are widening in the foundation of physics, right now, today. The revolution is coming, whether we're ready for it or not, inevitably. We're watching physics break in real time, at CERN and other facilities. And nobody outside the physics community is talking about it yet publicly.